Hello everyone, can you see the reddish color of the sun as it is sunset? Can you tell me the reason why the sun is red at this time? And also, as you can see, the sky, it is in blue in color, and we have the white clouds here. The sky is blue, and as you can see, there you have the reddish sun. So we are going to discuss the reasons for why the sunset is reddish in color and the sunrise is also reddish in color, and why the sky is in blue, and why the clouds are white in color. So that belongs to the topic of dispersion and scattering, and today is our topic of dispersion and scattering, and let us know these terms and also its applications in our daily life. You might have seen rainbow during rainfall along with the sunlight, right? And also you might have seen near to the water ponds near the garden or near to the rainfall. So how does this rainbow occurs? So now let us see the formation of rainbow. So for that we need a white light and also the water droplets. But how does the water droplets and the white light combine to form the rainbow formation? So let us see. So the white light and water droplets are the most two important things for the formation of rainbow. So it occurs a phenomena which is called the refraction and total internal reflection. So as these topics we have discussed, these definitions we have discussed, so let us see how does a rainbow occurs. So suppose you have been standing on the ground and you have been seeing a rainbow at a little bit far away distance. The first thing you see is the red, orange, yellow, green, blue, indigo and violet. So it's in an order that you see here. As the indigo is little bit cannot be seen, as it is little bit cannot be seen due to low intensity. So the rainbow is formed due to the presence of water droplets in the atmosphere with the help of the refraction and the total internal reflections. So as this, how the light comes to us, falls into our near to us, and we see the objects, the same way also the light which is coming from the rainbow come near to us and sees. So all the colors appear to us. But how does this color appear to us? So let us see here. So we have a water droplet, and as it is a white light, it is coming from the rarer medium, that is the air. So we have taken as a normal. So some of the light is been reflected and some of the light will be refract into the water medium. As a reflection of light doesn't need any important here. Why? Because it is not involved in the formation of rainbow. So we take only the refracted ray here. So the white light, as we know, it is a combination of the 7 colors, that is VBGR, 7 colors. So when you insert a prism, it produces the 7 colors here. The same thing also happens for a single water droplet when the white light enters into it. So it splits into seven colors. So that is what we call as the dispersion. The process of splitting white light into several colors, and again it undergoes reflection over there. But at that point, at that surface, why it undergoes reflection? So why it can't go refraction? That means why can't it come out like a prism, how it goes? So it undergoes reflection due to a concept we know, that the total internal reflection. So let us get briefly here. So when a light moves from denser medium to rarer medium, it moves away from the normal. And again, if we increase the angle of incidence, again it bends more. But at a particular angle which is called as the critical angle, so the refracted ray becomes perpendicular to the normal. That means it grazes along the surface. So the angle which we incident here is called the critical angle. The refracted ray becomes 90 degrees. And again, if we increase the angle, it undergoes reflection, which we call it as the total internal reflection without no loss of energy over here. So the same thing occurs here in the formation of rainbow inside the water droplet. So it undergoes reflection, and after total internal reflection, the 7 colors which we see here comes out in the form of refraction and being split it out in several directions. So here we have the refraction and the total internal reflection. But why do we see the red light first and the violet light down? So the main reason is what we call the angle of vision. So the angle of vision plays an important role over here. So the color which we appears here, as if we see for one water droplet, as we get the red color, if we consider the another water droplet, we get the violet. That means to our eyes we get the red and violet, which makes an angle of 40 to 42 degrees, and that we get the formation of rainbow. So when we discuss about the dispersion, so the first thing that we get into our mind is the prism. So dispersion, as it is the process of splitting of white light into several colors here. So as if you see in the prism, so we have several colors, that is violet, indigo, blue, green, yellow, orange and red. So as if you see, so violet is bending more when compared to red. So I have a question here, that why does the violet bends more when compared to red? So why does violet has the more bending property when compared to the red light? So for that we have here the reason, as we have the refractive index. So refractive index n is equals to c by v, and from this, as we have velocity is equals to f lambda, the formula. So if you substitute in this, we get f lambda. So from this c, as it is the constant, that is the velocity of light, and f is the frequency, as during refraction the frequency is constant. So we get n proportional to 1 by lambda. That means if the refractive index is more, the wavelength is less. If the refractive index is less, the wavelength is more. That means any light which has low wavelength, it has high refractive index, which means has high bending property. And any wavelength of light which is having more wavelength will be having less refractive index, so it will have less bending property. As if you see here, the red has more wavelength when compared to all the colors. So violet has 400 nanometers, or what we call 4000 angstroms of wavelength, and coming to red has 700 nanometers or 7000 angstroms of wavelength. So as red is having more wavelength, so it has less refractive index and they will be having less bending, so it has a bending property less. And when we discuss about violet has less wavelength, so it has more refractive index, so it bends more. So due to this reason, the violet bends more when compared to the red. So it is due to the wavelength over here. Now it's time to discuss about the blue sky, yellow sun or white sun, and the reddish orange sun. So let us discuss this. So before going to this, we need to discuss about the main important thing, that is, one is the atmosphere of the earth and the sunlight. So these two plays an important role over here. So now let us discuss about the sunlight. So the sunlight, white light, which is a combination of the 7 colors, which is considered of each and every color has a specific wavelength, as the violet with the lowest wavelength and the red color which has the highest wavelength over here. And coming to the atmosphere of the earth, so as we have a mixture of gases, the dust particles, the water droplets and water vapors. Now if we consider the gas, we have 78% of nitrogen in our atmosphere and oxygen with 21%, and the remaining gases of argon, carbon dioxide and the remaining other gases with 1% over here. So as in our atmosphere we have these gases like N2 and O2 molecules. So when sunlight enters into it, it scatters, that is the process in which the air molecules absorb sunlight and re-emit in various directions. So the emitting of the light in various directions will not be with the same intensity. It will be different intensity, and that is discovered by Rayleigh, the law of scattering. So the intensity of scattering light is inversely proportional to the fourth power of the wavelength of a wave. That is, I is proportional to 1 by lambda power 4. That means if the lambda increases, there will be less scattering, and if the lambda decreases, then there will be more scattering. That is, the intensities will be more. So as if we see, can you tell me which one has less scattering and which one has more scattering? Yes, the violet has less wavelength, so it scatters more. So we have violet, indigo and blue, and it re-emits in all directions, so due to the presence of the molecules. But why do we see the sky as blue color? So violet also has the less wavelength, so why can't we see the sky as the violet here? So as when compared to blue, violet scatters more and the blue scatters less. So as if we see the solar spectrum, that is the sun rays, the sunlight which coming from the light which is coming from the sun, the solar spectrum, you can see more. When compared to violet, blue is more visible to us. So that is the main reason we see the sky as blue color but not the violet color. And also we have another reason for that, as our human eye is more sensitive to blue when compared to violet. Now, what happened for the dust particles and water droplets? Do they get scattered? Yes, they also get scattered. So as the size of the dust particles and the water droplets are greater when compared to the size of the light wave. So the white light, which is combination of 7 colors, when they fall upon the gas particles, these dust particles, they emit all the colors as they are having greater size. So when all the color combines, so it appears to be white color. Now it's time to see that why the sunset or sunrise is yellow in color. That we are going to discuss now. So let's see discussing about the scattering, that why does the sun appears reddish orange during sunrise and sunset. As if you see, here we have the earth's surface and here we are living here. As when you compare to the morning and evening and the noon, so the morning time, that is during the sunrise or sunset, we are much far away from the sun, as there is more distance between them. So the white light which is coming from the sun, that means combination of all the colors, violet, indigo, blue, green, yellow, orange, red, so all these colors get scattered in between them. So when they get scattered, only the orange and the red color comes near to our eye. So that is the reason that we see the sunrise or sunset as the reddish. As you have seen starting the video, during the sunset we see the total sun become reddish orange, and also some of the color has been splashed out to the sky also here. So that is due to the scattering of light. All colors, the remaining all colors has been scattered. Why? Because they have less wavelength. So as they have less wavelength, so they scatter more, that means they bend more. That is why the violet color bends first, then next comes to the indigo, blue, green, yellow. As the orange and red, they have less wavelength, so they have more wavelength and they have less refractive index, so they bend less. So that is why they travel more distance with less bending, that is less scattering. So here we have less scattering, or what we call spreading also, we can call it as spreading also. But here for violet, as we have less wavelength, the refractive index is more and the bending is also more and the scattering has more. There is more scattering, that is why the remaining all colors has been scattered away, not reaching to us, and only the orange and the reddish come near to us. So that is why it appears to be as reddish orange color during the sunrise or sunset. But when coming to the noon time, so as there is less distance between the sun and us, the earth's surface, as there is less distance, so all the colors come near to us. So when all colors come near to us, they combine to form it as white light. So as there is no scattering of light, all the color come near to us and it appears to be as white color. So this is the reason why we have the sunrise or sunset as the reddish orange, and noontime we have white light. Now we'll be discussing about the application of atmospheric refraction. So as if we see, the position of the sun will be different when we see from the horizon. So that is, the sun is visible to us before the actual sunrise and after the sunset. So that is why, because the density of the air near the surface of the earth is slightly higher, so the rays of the sun coming through the space enter at the top of the earth atmosphere and travel from rarer to denser medium. So they bend slightly towards the normal and it appears to be coming from the apparent position. That means it is coming from the different positions. So hence the sun appears to be rise a few minutes before the actual sunrise, and the same phenomena is applicable for the delay of the sunset. So sun appears to be rise a few minutes before the actual sunrise, that is 2 minutes, and a delay of 2 minutes at the evening. So total 4 minutes of sunrise we will be having. And the apparent position of the twinkling of the stars, we see the stars twinkling at night. So that is also due to the atmospheric refraction, as the refractive index of the Earth's atmosphere is gradually changing due to the atmosphere gases. So it bends, and the straight line which is coming from the stars, it moves away from one point to another point. So it appears to be that it is coming from the another place. So the apparent position of the star is slightly higher than its actual position. So as the path of the rays of the light coming from the stars goes on varying slightly, the apparent position of the stars fluctuates and the amount of light entering the eye flickers. But the planets which are near to us, they won't flicker. So why? Because they are near to us, as the amount of light which is entering into the atmosphere, we won't see that type of flickerings. That cannot be observed clearly over here. So that is why the planets won't twinkle. And the color of the sky which we see from the moon is always black, whether it is a morning time or evening time. Why? Because due to that absence of the atmosphere over there. So due to the absence of the gas, there is no refraction, so we cannot see the colors. But when you compare to the earth, as we do have atmosphere with the N2 and O2 molecules, so due to that we see the sky as blue in color. So these are the applications of the atmospheric refractions. Thank you for watching the video. Please subscribe the channel, click the like button and give your valuable comment, and I will be waiting for your comment. Thank you for watching.